All right, guys, let's take a look at waves and what we need to know for this test. So we start off with these 5 questions, and we'll have these same 5 show up again at the end so that you can test yourself out on what we go over here. So the distance between the midline of a wave and its crest or trough, what is that called? Just basically be able to define wavelength. And which type of waves do the particles in the medium move parallel to the wave direction? That is a common question. Which type of wave has the largest wavelength? We need to know that for sure. And this last one, a very common question also. What has the smallest wavelength and the most energy of any wave in the electromagnetic spectrum? Okay. So we start off with wavelength and frequency. So a full wavelength is defined as the portion of the wave between 2 successive crests or between 2 troughs. By looking at how the crests and troughs line up with our horizontal axis, we can see that a full wavelength always takes the same amount of time. Frequency, so we definitely, very common that you would be tested on like being able to differentiate wavelength and frequency. Frequency is the number of cycles of a wave that pass a specific point in 1 second. So that's just really just a definition you have to have memorized. Excuse me. Wavelength and frequency are inversely proportional to each other. As frequencies increase on the electromagnetic spectrum, wavelengths decrease. Gamma rays have the highest frequencies, but the smallest wavelengths. Okay. And then with amplitude, so we just sort of have like a basic definition there, and that was our first question, right? The distance between the midline of a wave and its crest or trough is called what? Right? And if it was a multiple choice question, it would be with amplitude, frequency, wavelength, and something else. All right, there's our first question. Distance between the midline of a wave and its crest or trough, that is amplitude. Okay. If this was a wave traveling through water, amplitude would measure the maximum displacement of the particles from their resting point. And then types of waves. Okay, so we got quite a few, right? And so we want to be familiar with all of these and be able to provide an example would be great. If you can provide an example of a concept, usually that's a pretty good sign that you have a good understanding of it. Movement of a wave through a solid object, like stretched rope or a trampoline, that would be a good example of a transversal wave. Longitudinal waves have movement of the particles which are parallel to the motion of the energy. I believe that was one of our questions, was it not? Question 3 there. In which type of waves do the particles in the medium move parallel to the wave direction? Right? Longitudinal waves, particles are parallel to the motion of the energy. Sound waves moving through the air are an example of a longitudinal wave. For a sound wave traveling through air, the vibrations of the particles are best described as longitudinal. Okay. Transverse wave. A transverse wave can only travel through solids, but a longitudinal wave, for example, can travel through solids, liquids, or gases. Surface waves have particles travel in a circular motion. Examples of this, like the most common example would be waves in the ocean. Radio waves have photons with low energies. Radio waves have the largest wavelength. And then finally, microwaves can be used to broadcast information through space. They're good for transmitting information because the energy can go through substances such as clouds and light rain. Forms of electromagnetic radiation include gamma rays, X-rays, ultraviolet light, visible light, infrared, microwaves, and radio waves. And yes, you'd like to be familiar with all those examples. Electromagnetic radiation is energy that is transferred through free space or through a medium in the form of electromagnetic waves, such as radio waves, visible light, or gamma rays. And just a quick point about gamma rays. We already referenced them earlier, but gamma rays have the smallest wavelengths and the most energy of any wave in the electromagnetic spectrum. That is a common question, so I would have that locked into my mind, while a mechanical wave is a wave that is an oscillation of matter and therefore transfers energy through a medium. Okay, so that gets us back to our 5 questions. And so it's a great time to hit that pause button and test yourself out on these concepts.